In a world of ever-increasing population and consumption and decreasing resources, industry is constantly looking at new ways of recycling. To meet our ever-increasing demands on resources, we must be able to maintain the infrastructures which support our everyday lifelines as efficiently as possible. It is with this in mind that the Powerbeam system has been developed, a unique restoration system dedicated to preservation of existing power poles. The system is inherently simple, sophisticated in engineering and inexpensive to install and manage, resulting in extending the life of power poles significantly, with an installation process taking no longer than 20 minutes on average. In short, Powerbeam has been made to last, setting new standards within the industry. The humble power pole proliferated just after the Second World War, and there are now millions throughout Australia. Their condition varies, but they will all eventually need replacement. By the very nature of a wooden power pole's properties, it is prone to rotting. Above ground, a pole may last between 60 and 80 years. However, it's at ground level that the life of the pole is reduced approximately by half. Deterioration of wooden utility poles occurs first at ground level, caused by moisture and fungal rot. The weakened section is generally short. Replacement of the pole is the traditional and very expensive option. However, at approximately 1/3 of the cost of replacement, the Powerbeam system is time efficient and inexpensive, as well as being environmentally friendly. No other reinstatement system is as technically advanced and as capable as the Powerbeam technology. The unique design of Powerbeam makes it possible to reinstate over 95% of all timber poles. The Powerbeam system is an advanced reinstatement technology, incorporating a range of vertical beams and connectors, which when installed, form a new composite pole. This technology is separate and substantially different from other systems, and is protected by intellectual property, copyright, patents, and registered design. The Powerbeam system consists of 3 main components: a range of compound fabricated beams, from the micro system for lightly laden and telecommunication poles, to the double large system for complex poles. The beams all incorporate the unique hollow reinforcing spine, specifically designed backplates and tapered connectors. These components, combined with bolts and stainless steel strapping, form the Powerbeam structure, which will maintain the integrity and substantially extend the life of any power pole. The design and testing of the Powerbeam have been extensive. All Powerbeam systems have been designed to fail in a ductile manner, with tests clearly demonstrating this. Tests show that the beam is still able to support the weight of the pole, even though it is leaning at an angle of 50 degrees or more to the vertical. With this significant design feature, there is plenty of warning and time to take corrective action, with no interruption to services and no possible danger of conductor contact to the general public. The main function of the beam is to bridge the gap between the sound sections of the pole, below and above ground level. Therefore, the bending and torsional strength of the beam must be sufficient to withstand the various loads arising from wind, conductors, maintenance, etc., normally applied to a pole. The bending strength is provided by the cross-section acting as a beam with 2 principal axes of bending. The torsional strength, which is required both during erection of a power line and when a single conductor fails, is provided mainly by the beam's tubular spine. The Powerbeam installation process is quick and efficient, and it's a go-anywhere system. The Powerbeam offers approximately the same strength in all directions. This enhances installation capabilities because the beam can be placed in the most convenient position around the pole to avoid underground services and above-ground assets. The purpose-built articulated tractor rig makes it possible for installations to be performed in suburban and built-up areas and off-road rural situations, including steep gradients and even flooded marshlands. The installation rigs are manned by 2-man teams, extensively trained to adhere to regulatory requirements and occupational health and safety. It is usual for an installation crew to complete 8 to 10 reinstatements a day. The installation process includes the following basic steps. The workplace is inspected and made safe. The beam is driven into the ground adjacent to the pole. Bolt holes are drilled through the pole, and the entrances to these holes are tapered with a specifically designed reamer. An antifungal grease is applied to the reamed holes to seal the envelope of the structure. Bolts are inserted to couple the back plates and connectors to the assembly. The pole is tagged and the worksite is tidy.